In this video we are discussing fringe width. So fringe width means it is the width of the bright fringe and dark fringe. Alright, so to get the fringe width, what we are supposed to do, how to calculate the fringe width. Suppose this one we are calculating the width of any bright fringe. Suppose this bright fringe. Okay, wait. Suppose we want to find out the fringe width of this bright fringe, this one. What shall we do then? Can we do one thing? Can we take the distance of this dark fringe from the center, which is suppose y n plus 1, order is nth plus 1, and if you take the distance of this dark fringe from C, this one, suppose this is yn, it is yn and it is yn plus 1, it is just below this, no, below this, so n, then next one should be how much, n plus 1. If you subtract yn plus 1 minus yn, which one you will get, which part? Isn't it the width of this bright? So can we say that the width of a bright fringe can be calculated by subtracting the consecutive position, or by subtracting the position of two consecutive dark fringe. Here which two consecutive dark fringe we took? From here to this C, this was yn plus 1, one dark fringe. Next was from here to here C, this was yn. So two consecutive dark fringe we have taken. Okay, if you subtract, then we are getting the width of a bright fringe. This one we are getting. Alright, similarly, if you want to find out the width of a dark fringe, then what we are supposed to do? Suppose you want to calculate the width of this dark fringe. What we will do, from C to this bright fringe, suppose the distance is again yn plus 1, and this bright fringe, distance is from C, is suppose yn. Now if you subtract yn plus 1 minus yn, which one you are going to get? This dark fringe, the width of this dark fringe, isn't it? So the width of a dark fringe can be obtained by subtracting the position of two consecutive bright fringe, and the width of bright fringe can be obtained by subtracting the position of two consecutive dark fringe. Alright, so that's what we have done here. Okay, I have written here fringe width, distance between two consecutive bright or dark fringe. If you want to find out the width of bright fringe, we will take two consecutive dark fringe and we will subtract their position. If you want to find out the width of a dark fringe, we will take two consecutive position of bright fringe. Okay, so here we are finding bright fringe, so yn will be the position of which fringe? N plus 1th fringe, but that should be a dark fringe. So for dark fringe, this is the formula. But since it is yn plus 1, in place of this n, we should write n plus 1. Okay, so that's what we have done here. Alright, 2n minus 1, so minus 1 is here, lambda d by 2d. Next, minus yn. So yn means, now here it was n for nth fringe only, so there will be no change, it will be n only. Do the simplification, lambda d take common, this one will come inside, 2 and 2n get cancelled, 2 will get cancelled, we got this one. So this is the fringe width of what? Bright fringe. It is given by beta, lambda d by d. Similarly, two dark fringe we have taken to find the width of a bright fringe. We have taken the two bright fringe to find out the width of a dark fringe. Okay, so for bright fringe, this is the formula. So for yn plus 1, in place of this n you should write n plus 1, so n plus 1, then minus, for yn there will be n only, no? So if you subtract, lambda d take common, n plus 1 minus 1, n get cancelled, again we got lambda d by d. So aren't the same? The width of bright fringe and the width of dark fringe are same only. Okay, so I hope this part is clear. Then we will proceed to one sum. Okay, it is given that in Young's double slit experiment, if lambda is equal to 6000 angstrom, then first maximum is obtained at this much meter from the central maximum. So this is nothing but the value of y. First maximum. So first maximum means the value of n will be 1, not central maximum, first maximum. Okay. Anyways, now what happened is, if the wavelength becomes 4000 angstrom, where will you get the fourth minimum? Fourth minimum you have to find out. That means y4 minimum. Minimum means dark. So y4 you have to find out for dark fringe, and given is which one? Y1 is given for bright fringe. Okay, y1 for bright fringe. So first of all we will write y1. Y1 is this value, yn was equal to, for nth one, no, it was n lambda d by d. So here first means this n will be 1, so I wrote here y1, and this n is also 1, so this will be this one. Okay, since n is 1. So this y1 is given 0.2 meter. Alright, lambda is given 6000 angstrom, so I made it in meter. 6000 into 10 to the power minus 10, d will remain as it is, as the values are not given. This is given equation number 1. Then what you have to find out is y4 for dark. Okay, so for dark, what was the general expression? Y, you can write y or yn, same thing, huh? So for that, the expression was, what was that? Twice n minus 1 lambda d by 2d. Here fourth, so fourth means n is how much? 4. So that's what I have written, 2 into 4 minus 1 lambda d by 2d. This is 7, 4000 angstrom I have converted to meter. dd will remain as it is. So what you have to find out is y4. Divide it 2 by 1. If you do 2 by 1, this capital D, small d, unknown terms will get cancelled. We got this one. Do the calculation. Almost things will get cancelled, like 10 to the power minus 10 get cancelled. 3 zeros got cancelled. So finally we will get this one, 0.466 meter. This is the distance of the fourth minimum. Minimum means dark, maximum means it is bright. Okay, from where we are measuring this, all these distances? From the central maximum, isn't it? Because y is nothing but the distances that we are measuring from the central maximum. This one, y. From where we are measuring these distances? From C, from the central maximum. Okay, so I think this much is clear. Then in next class we will discuss about diffraction.